So here we are talking about linear regression. So we need to understand the meaning of term linear regression first before we understand that what all the concepts and all the things are there. So here we will only talk about the two variable linear regression, where one variable is dependent and another variable is independent. Now what is dependent and independent variable, we will get to that also, but first we should know that what the word linear regression means. So linear in linear regression means a straight line relationship. Linear means a straight line relationship between the variables. That is what linear means, we all know that. Then regression basically means that there is a relationship between the two variables, and with the help of this relationship we can find the value of one variable from the values of the other variable. That is the, say for example, we have income and demand. So if we have values of income given, so we can find out the values of demand. That is what regression means here. That is what this means, that from the values of one variable we are going to find the values of another variable. So this is the basic meaning of term linear regression, although it is not just that, there are many other things also, but that we will get to as we move ahead. Okay, so linear regression analysis, as it says, that it is concerned with the study of relationship between one variable, that is called the explained or the dependent variable, explained or dependent variable, and the other variable, that is independent or explanatory, that is explained or dependent variable with the independent variable or unexplained variable, you can say. So what does explained and unexplained variable means? That now see, if we have income given, right, our demand and our income, so basically our demand will always depend upon this income values. Say 10, income is 10, income is 20, income is 30, 40. Our demand will depend on this, although it depends on other factors also. That is a part of multiple regression that we can think about in multiple regression, but here we are thinking about only two variable regression, that is we have demand values and we have income values. So जैसे जैसे इनकम बढ़ती जाएगी वैसे वैसे डिमांड भी बढ़ती जाएगी. तो डिमांड जो है यहाँ पर हमारी सिर्फ इनकम पर डिपेंड कर रही है. डिमांड इज ओनली डिपेंडेंट ऑन इनकम हेयर, राइट, ओनली डिपेंडेंट ऑन इनकम. So when this thing we talked about this, that demand and income. So here our demand, since it is dependent on income, demand is our dependent variable and income is our independent variable. This independent variable will take values and those values will affect our dependent variable, right? So in other words, that is explained and explanatory. So demand is our explained variable, that is it is explained by income, and income is explanatory, that is it explains the demand. So this is the meaning of these things, that explained and explanatory variable here. Okay, so now they have given us some examples here, that we may be interested in finding out how the sales of a product are related to the advertising expenditure, right? Sales related to एडवर्टाइजिंग एक्सपेंडिचर. जैसे जैसे एडवर्टीजमेंट बढ़ेगी वैसे वैसे सेल्स बढ़ेंगी. तो वो रिलेशन को हम लीनियर रिग्रेशन से फाइंड कर सकते हैं. ऐसे ही एक और एग्जांपल दिए इसने यहाँ पे, दैट इज रिलेशनशिप बिटवीन जीडीपी एंड डिफेंस एक्सपेंडिचर. एज आर जीडीपी इंक्रीजेस आर डिफेंस एक्सपेंडिचर इज गोइंग टू इंक्रीज, और एज इट डिक्रीजेस आर डिफेंस एक्सपेंडिचर इज गोइंग टू डिक्रीज. दैट इज ऑल्सो अ रिलेशनशिप. सो सच रिलेशनशिप्स आर डन बाय दिस linear regression. Now next thing is that what this says is that relationship between two variables, that is like we said before, that relationship between say income and your demand, this always does not imply causation. Causation means that cause and effect relationship, you understand, like income and demand, so there is a causation because there is an economic theory, law of demand. Now for income, say how is demand affected, that is economically explained, but always it might not be true that if two variables are related, that means that there is a cause and effect relationship between them. Okay, causality has to be backed by an economic theory. There has to be an economic theory that must back our causality. Just because they are related, we can see it from the linear relationship, does not mean that there is a causality between two variables. Okay, now what are the objectives of regression analysis? Why do we do regression analysis? So some of the major objectives are that we need to estimate mean, what we call average, or we want to find the value of the dependent variable. Like in income and demand example only, we need to find the values of these demand variables, that what is the demand for various income levels that is what we need to find. That is one of the that is an objective, that we need to find the value of the dependent variable. Okay, now from this we can also say that I mean that the prediction, for prediction we use the regression analysis. ठीक है, ट्रेंड एनालाइज करने के लिए, दैट हाउ इज लाइक इनकम एंड डिमांड पे ही हम फिर से आएंगे, बिकॉज दिस इज सिंपलेस्ट एग्जांपल एंड इजी टू अंडरस्टैंड दैट हाउ इनकम चेंजेस, लाइक ऊपर नीचे इनकम जा रही है, तो डिमांड में हाउ इज द ट्रेंड देयर, राइट. इफ नेशनल इनकम एंड 2021 वॉज सच, 2022 की दे रखी है, 2023 की दे रखी है, सो हाउ इज डिमांड चेंज. So it shows the trend, that what the trend was and what the trend is, right. Then causal relationship, that is there a cause and effect relationship. Cause and effect relationship मतलब होता है कि जैसे if I am changing a variable, say x, does it affect y consistently, like if increases, like say price and demand, we say, right? A sort of relationship, right, price and demand. So that type of relationship is what we try to find out by linear regression. Then there is impact measurement also, that is introduced to understand what impact measurement means. So moving ahead, now we come to the population regression function. So to understand the population regression function, we take an example of this SAT score example. This is a very classic example and most of the books have this example only. Gujarati also has this example. So what happens there is that in this we have two variables. One is the scores of student and the another is the family income of the students, right. So we try to find out that on various levels of family income, what are the scores that students are getting. So what we have here is that we have the population data of 100 students, that is there are 100 students in a school or in a class, and we have all of their data, that is we have data of all 100 students, their family incomes and their scores, right. So that data here, we have that data, right. So if we look here, so these are the income values, right, 5,000, 15,000, 25,000, 35,000 and so on to 150,000, right. And these are their scores, right. These are the scores of individual students. So on a particular income level, say 5,000, these are 10 students having their score, that is 460, 470, 460, 420 and so on till 490, and the mean here is 452. ऐसे ही हर इनकम लेवल पे जितने 10 बच्चों का स्कोर है उसका एक मीन दे रखा है, ठीक है. Another thing you should remember here is that this whole thing, this is population data, right. This is not a sample data, this is population data. Population data and sample data means that population is, say there are 100 people, right. This is population, and I can take, if I take data of 10 people, that is a sample. This is the difference between the population data and the sample data, and mostly we have sample data only because population is usually very large. Like for example, अगर इंडिया की population इतनी ज़्यादा है तो उसकी हम पूरा, we can't get whole data of the whole population. We have to get the data of a smaller size, that is a sample data. So that is the difference between population and sample. So we get the data here, right. So on the basis of this data, we draw this scatter plot, right. On this scatter plot, what we have is that say here we had this where is pen, here we had 5,000 family income. On 5,000 family income we had different values, that is this value, this value, this value, this value, this value, and this and so on. We have plotted all the values. Now the mean value is this. We have circled mean value on each income level, 5,000, 10,000, 15,000. At all the values we have these mean values, right. Now as I've written here also, that the circles represent the conditional mean. Now what conditional mean here means is that given a certain income level, you are taking the mean. Okay, the mean is not of whole data, पूरे data का mean नहीं है यहाँ पे, ठीक है. The mean is only given that I have told you that 5,000 is income level, then what is the mean? You say that ठीक है इतना mean है ना. And given 4,000, what is the mean? You say यहाँ पर है mean, ऐसे. That mean, this mean we had also here. If we see our data also, this mean thing we had here also, right. यहाँ पर हमने देखा ये हमने यहाँ पे these values 452, 475. These are the mean values. These are the conditional mean values. That given that 5,000 income, what is the mean? Mean is 452. In that way, it is written there that this is the conditional mean value. Okay. So we have written this equation, right? That is, we are getting the expected value of y given xi. Xi is our income and y is our score of the students, income and score of the student. Now the question is that what are these two things, beta 1, beta 2, xi. So xi is, so we know that it is income. Beta 2 is the slope. Beta 2 is the slope of this line, right? Beta 2 is the slope of this line, and beta 1 is intercept. Intercept means that from where the line starts, the intercept of y-axis. Okay, the intercept of y-axis. We get intercept by putting the income equal to 0. We get the intercept, that even if there is 0 income, some score would be there. That is where we will start from, right? Here there is no such thing, but in some situations we have this intercept. When our line will touch, this line will touch this y-axis. Okay. Now talking about the equation. Okay, so this is what it says, right? That e y xi, beta 1, beta 2, xi. It says that the expected value of y corresponding to or conditional upon the value of x, that is conditional mean. Expected value of y given xi, conditional mean है ना. The subscript I refers to the I subpopulation. I तो पता ही है, stats में भी होता है, सब में होता है I. What is I, right? Now that is the example that I told you just a few minutes earlier, that expected value जब हमने निकाली xi की, तो हमने बोला कि इनकम 5,000 है, तो मीन क्या है? So this value turns out to be 452. That was there in the table, right? Which is the mean or the expected value of the y in the subpopulation. Now what this equation is? This equation is our population regression function. Okay, this equation is population regression function and it represents the regression line in the population as a whole. ठीक है, पूरी population का डेटा था, हमने उसकी regress किया. We haven't regressed it. मतलब what the equation of that line is basically, that is what this tells us कि जो स्क्वैटर प्लॉट से जो लाइन निकली है उसकी इक्वेशन क्या है ना, उसकी इक्वेशन क्या है? हाउ कैन वी गेट दैट लाइन? Now we had this line there, this one, that expected value y की. One more thing, that we can write expected value of y also in place of writing whole expected value y xi. Okay, we can write this also. So this beta 1 is intercept, beta 2 is slope, right? Now what does this slope means? Say beta 2 अगर किसी इक्वेशन में है ना, किसी इक्वेशन में जहाँ in this equation only, if our beta 2 is 0.5, beta 2 0.5 means that if this variable, if our income increases by $1, then our score will increase by 0.5. That is what beta 2 will mean. Okay, so this beta 1 and beta 2, these are called parameters. Beta 1 and beta 2 are called parameters, also known as regression coefficients. Beta 1 and beta 2 are parameters or regression coefficients, are parameters or regression coefficients. And beta 1 is known as intercept, that I have told you. Beta 2 is slope. The slope coefficient measures the rate of the change of the mean value of y per unit of change of x. That I also told you, that what this means, beta 2, that as our income or our dependent variable, as our independent variable of whose the coefficient this is, like here it is coefficient of our income, as our independent variable increases by 1 unit, how much it will affect our dependent variable. That is what beta 2 will mean here. I hope this is clear till here, that we found out this equation beta 1 plus beta 2 xi. This is very important equation for regression. Okay, and you should understand what it means. We understood the meaning of this beta 2 and beta 1 parameters. Beta 1 is intercept parameter, this is slope parameter, and this is our income value or our independent variable. Okay, till here it must be clear. Now we come back to our table. Okay, in our table we said that mean is 452, mean is 457, mean is this. Okay, now here see mean is 428, or in all you can see, and the first value is 530, that is above your mean value. This value is 500, that is below your mean value. So when you make the equation, this equation expected value of y beta 1 plus beta 2x, you are going to plot this equation also, right? You will plot this equation also. So you plot this equation like it has been plotted here. Okay, this line is what you have plotted using this equation, this part, right? But we only saw that there is a difference here. Also there was a value here 530. Now how do we explain, how do we include these values in our model? So we use the term u. U is our error term. U is our error term slash a random term slash noise term. All these names are for u. Okay, so we put it here at the end of our equation. We put this u value at the end of our equation. Okay, so now this part of the equation that we get using the data, this is called systematic part. Systematic part slash deterministic part. That is, it can be determined. Changes in this part are systematic. How are they systematic? Because of the parameters. There is a intercept parameter. जैसे जैसे x की वैल्यू बढ़ेगी वैसे वैसे due to the beta 2 coefficient our y value also increases. That is the systematic part. This equation, this part moves systematically, so we call this a systematic part. But our ui is, it is random. This part is not there in the equation. This part is not there in the equation. Say you have an income of say 5,000 वाला example लेते हैं, that you have income of 5,000. So by the systematic part, what you will get is that your score will be 452, right? But your score turns out to be 470. So how are you going to explain it? That this difference in 470 and 452 here, this difference in these two things is your error. You can't explain everything in your model. That is why you include the error term. Okay, you include the error term. Now that is what it says here also, that all I have explained all these things, that this is the systematic part, this is the non-systematic part. Your error term is stochastic, random, or you can call this u as stochastic term, random term, or error term, whatever you want to call it, you can call it that way. And the error term is a random variable, that we also know because we do not know the value of it, as we have seen in the example also, that if income is 5,000 and our mean, what our deterministic part shows a certain value, say 450, and we get 457 as our original score, as our real score. So this 7 is random, right? This number can change, but this number will always be deterministic, or we can always get this number using our equation. But this is a random part, your error term, right? So that is what it means, right? So error term is a random variable. Okay, we also call it noise component. It is a noise term in our data. That is just similar to what actual noise means, right? Now moving ahead, we see that so what we have already read here, that this is the equation, this is the deterministic part. If we take this whole equation, then it is called the stochastic PRF. This is called stochastic population regression function. This is non-stochastic PRF. This is non-stochastic PRF just because of this random error term. Okay. So now we need to understand that what is the nature of this error term. Okay, what is the nature of this error term? So what it says here is that the error term, it represents the variables that are not included in the model. Now what does this mean, that variables that are not included in the model? I told in the starting that this is a two variable model. right? Two variable model. In for example, say income and demand thing, we know that demand is affected by other variables also, like price of the good, price of the substitutes, price of the complementaries, right? Your tastes and preference, taste and preference, and there are many other factors. So we are not including all those factors. These lead to our error. Similarly, in our SAT example, we only took income and score. There are other variables also that affect our scores. What is your IQ level? We could have included that also, right? And there are many such variables that you can think of. So such missed variables lead to the error. That is IU in population. That is in population data. Okay, so this is the first feature of this error term, or why the error term is there. Now, second is that human behavior is not predictable. Human behavior is not predictable. The student might not have studied that day, even with the income of say 100,000. He might get a very low score. So it could be that he did not study that day. So you can't predict that using a model, right? And then there could also be errors in measurement, that someone from a lower income might be counted in a higher income group. That could also lead to error. Then sometimes what happens is that we deliberately leave some relevant variables because we believe that the effect of those variables is negligible on the dependent variable. So that is why we leave those variables, and those small changes, they also lead to error. Sometimes this thing of deliberately leaving this was given by the Occam's razor principle. Okay, you can read this from the book also, principle of Occam's razor. Now we come to our sample regression function. Now what we did earlier was a population regression function, and I said there also that we always do not have the population data. Okay, that is what it says also, that in practice we rarely have the entire population at our disposal. Okay, so often what we have is only population. Often what we have is only sample data, right? So from sample data we have to make predictions such that it represents the population data. Okay, so what we try to do is, from sample we try to estimate the population regression function. From SRF we try to get the PRF in a way. Okay, so our estimates of PRF may not be entirely correct. Okay, our estimates of PRF may not be entirely correct, that we did earlier, due to sampling fluctuations or error in sampling and many other things that we read in the error term also. Those could also lead to the incorrect estimates, right? So here, from the earlier data, we take two random samples. Okay, we take two random samples, say like this, that these are the various your scores and these are their income levels. These are your scores, these are your income levels. Okay, what we do with this is that we plot these on the scatter graph. Okay, like this we plot them. Now there are these are the values. These are sample 1 values, the black dots. These are from sample 1 and these are from sample 2. The sample 1 shows, if we look at this, the sample 1 is going like this, ऊपर ऐसे. So we make a sample regression line, okay, for sample 1. Similarly, line for sample regression of second sample. Okay, these lines are the lines that fit the scatter plot. That is, they show the trend, that where our data is moving. Our data is moving like this, है ना. अब यहाँ पर we can't draw it like this because data, we can see the data is moving like this. Okay, these things are nowadays mostly done by computers only, using different apps and various different programming languages. We can get this easily using Excel also. We can get this, that you click the option of fitting the line on your scatter plot and you get the line. Now this time we, instead of PRF, instead of population regression function, we draw a sample regression function. Okay, what we have in sample regression function is that, say y hat equal to b1 b2 xi. We are using the small letters here to indicate that this is a sample regression function, not population regression function. Hat is indicating that this is an estimated value. Okay, so y I hat is estimator of your conditional mean your scores that we had earlier. Okay, and beta 1 is going to estimate our this beta 1, beta 2 estimates the beta 2, beta 2 estimates beta 2. Now an estimator or sample statistic is a rule or a formula that suggests how we can estimate a population parameter at hand. Okay, this estimator is a rule or a formula that suggests that how we are going to reach here at a population regression function or population values. Population regression function will determine the population values, है ना? So how we will reach there, that is what this estimator is doing. So the thing is that when we made a scatter plot, so all our sample data did not lie on the sample regression lines, right? Here we can see that यहाँ पर है data is here, but line is here, line is this only, the SLR1, है ना? It is not lying on the entirely on the line. So here also there is an error, like we earlier did the error thing, right? Here also there is an error, है ना? यहाँ पर भी error है. So we include an error term here also. And we make a stochastic version of our sampling regression line, and here our error term is EI. This we call residual term. Then whatever is left, residue, you know that residue means that whatever is left, right? So this is a residual term. Okay, so moving ahead, what our residual term actually is that, see, this line is like this, okay, and this is our actual value, and this is what we have predicted using the sample value, that is why this line is here. So this residual term EI is actually a difference between your actual value minus the estimated value. Your actual value is yi and your estimated value is yi hat, that you are estimating. We estimated this only equal to b1 plus b2 xi, right? So this is your estimated value and your actual value is yi, that was the population value. So EI is actual value minus the estimated value. Okay, so this is population regression function. This is what we want, and this is what we use to get it, because we do not have the population data, we have sample data, so we use this to get our population regression function. Okay, now more explanation on this sampling regression function and population regression function difference is that this line, PRF line that you can see here, this PRF line, population regression function line. Okay, so now actual value was here, yn. Okay, actual value is here. Now there is an error with the population regression function that we called un. Now the error with the sampling regression function is en. Okay, en, the actual value minus the estimated value. This is the actual value minus the estimated value. You can say it also here that this is the actual value and this is the estimated value, and the difference here is your residual, and here it is error term with the population. So now our population regression function can be expressed like this. Now how are we expressing it like this? Because we had this thing was beta 1 plus beta 2 xi, right? Initially we did this plus your error, so you get the population regression function. You can write this as yi equal to expected value y xi plus ui. Okay, you can write this, because in estimating the mean there is no error. In estimating the mean, when we did this line for our population values, when we did this line, when we did this population PRF line, these were various mean values. There is no error on mean values. The error is on population values. This is the error. So that is what we are writing it like this, that this is the mean value plus whatever the error you have, you will get the population value. Is it understandable? What I will explain this again also, that say our mean value was 570, right? And our population value is 575. So error is 5. We can write this 575 as 570 plus 5. This is your expected value of y given xi. This is your mean and this is your ui. That is how we are writing PRF like this here. Okay. So there could be an overestimation and underestimation of this value here because of this also, and also sampling fluctuations. So that could be there, and we try to find the best fitting sample regression function that can mirror this PRF function. We try to get a sampling regression function that can best look similar to this or mirror the results of this PRF. Okay, because we do not have the population data mostly, that is why. So moving ahead, so we are now trying to understand that what the linear thing means here. So linearity is as simple as it could be, that we cannot have squares with our variables. We cannot have our variables like this, because when we have our variables like this and this, or say x cube or any other functional form, we only need it to the power 1. Why? Because if we have these things, then our slope will not be constant. Our graph will go like this. We want the graph to be linear. For that, our slope has to be constant, and for the slope to be constant, these independent variables should be of power 1 only to keep this constant. Okay, moving ahead. Yeah, so here they have shown it with a graph also, that this is the linear graph with power 1, and this is a non-linear graph. This we cannot deal with because this is not very predictable, and we are only talking about the linear regression here. Now there is also concept of linearity in parameter, that betas and this betas can be, but we do not generally take this. We do not generally do this. It could be non-linear in parameters, but we mostly deal with the equation where the parameters are also linear. Okay, where the parameters are also linear. Now small peek into the multiple linear regression is what we have here, that in multiple linear regression we include all the variables that we want to include, and they all have their separate your coefficients, your parameters. So this will be dealt in the subsequent chapters, and here this whole part is your expected value of y, that is your your PRF plus your error. Okay, error is also there, but we will talk about this when we are doing multiple regression only. Now we come to the method of how we find out the regression line. Okay, the estimation of parameters. How are we going to estimate these parameters, that this beta 1, this beta 2, we said कि भाई equation बनाएंगे हम यहाँ पर ऐसे beta 2 xi, but how are we going to get values for these two things? How are we going to get the intercept, the slope? How will we reach these values? So that is what we will be talking about now. So it is mostly mathematical only. It is mostly mathematical only, and you have to remember the formulas of beta 1 and beta 2 that are important. Mathematical part you can try to solve, or you can easily solve using, there are various derivations, you can use them. I can show what the book has to offer. So here we had our equation, PRF equation. Okay, beta capital B capital beta 2 and this error term, and we had our sample also, small beta 1 small beta 2, and your this residual term. Now what your residual term, we also discussed this, that it is the actual minus the predicted, or actual minus the what we estimated, that is y hat. Now this y hat, we get this y hat, we had this as y hat equal to beta 1 minus plus beta 2 xi, right? So we substitute it here, and we get this equation. Okay, so now we have to choose beta 1 and beta 2, the estimators of capital beta 1 beta 2, in such a way that the residuals ei that are residual this residual is as small as possible. We have to minimize this thing. That is, we have to minimize this thing. Keep this as small as possible. So in OLS, ordinary least squares, what we do is that we try to minimize the square of this, square of our error. We try to minimize the square of our error. So this is what we are trying to minimize, and this is the equation that we have. Okay, now moving ahead, we will get these two normal equations. Now the question arises that how are we getting these two normal equations? That we will see in the appendix of this chapter. Here we can see that we have this equation. What we did is that we differentiated it with respect to small b1 first. We got this equation. Then we differentiated it with respect to small b2 first. We got this equation. Now with the first order conditions of minimization, we equate them to 0, and when we equate them to 0, we get these two normal equations. Okay, we get these two normal equations here. Now we know how we got these two equations, right? We got these two equations by differentiating it. We got these two normal equations by differentiating our ei square with respect to b1 and b2. Now these are two simultaneous equations, and when we will solve them, you can solve them on your own or use some tool, AI tool or anything. You will get this easily, and you get these two values. For beta 1 you get this, and for beta 2 you get this. These two values are our OLS estimators. These are our values of how we get our beta 1 and how we get our beta 2 values. This is how we will get to our beta 1 and beta 2 values. Okay. Now some of the features of our this beta 1 and beta 2 values is that first is this only, that this is our SRF, right? The SRF obtained. Now the mean value of the residuals. Okay, the mean value of the residuals is always 0. Mean value of residual will always be 0. That is, your errors mean value is going to be always 0. Second thing is that there is no correlation between your error and your dependent variable, that is x. Okay, that is summation ei x equal to 0. There is no correlation, that is, they are uncorrelated. Third is that the sum product of the residuals ei and the estimated yi, the sum product of the residuals, that is this, is also going to be 0. Yi is your dependent variable, right? Sorry, yi is your independent variable. Here it is independent variable x. So it is uncorrelated with dependent variable. It is uncorrelated with independent variable also. These are your some features of your OLS estimators. After this, you have some examples in your Gujarati which you can read, and so that you will get better understanding of the concepts. Okay, so it has shown various examples, various realistic examples, practical examples that could help to understand the concepts better. So that is it for this chapter of the linear regression of two variables, and we will see about the multiple regression in later videos.